So good afternoon. Today subject I am going to teach in real analysis in that BSc Mathematics, one of the major topic. Today my topic is derivative and set of measure zero. So I am going to cover today derivative and set of measure zero, one of the important portion. What is derivative? Let us see the definition. Let f be a real value function on an interval. Okay, J containing R1. If C belongs to, you take C from J, we say that f is a derivative at C. This is a condition. Limit x tends to C, f of x minus f of C divided by x minus C. The limit exists, that means we get some value. We denote that it by, this is a notation of derivative, f dash of C. That is equal to f dash of C equal to limit x tends to C, f of x minus f of C by x minus C. If the limit of RHS should be exists. When you substitute this value on the point C, value should exist in the RHS. Then we say it's a derivative. You know the differentiation. We used to do the differentiation like school level. Now when you differentiation f of x equal to sin x. What is the differentiation of f dash? This is cos x. Everything is based on the derivative. So you know differentiation very well. Here we can just see the derivatives. Let us see the note. Limit x tends to C, f of x minus f of C plus x minus means the same as, sometimes we used to see f of C plus x. Yeah, both are the same meaning based on the author. Instead of f as a derivative, we sometimes say f dash of C exists. F dash of C is called this is called a first derivative. This is called a second derivative. First derivative f dash of C, second derivative f double dash of C at C. Okay, this is the notation. Just we need to say notation. What is first derivative? What is second derivative? Now let us see the properties of derivatives. We see some properties of derivatives. The theorem 7.5. The real value function f as a derivative at a point C, then f is continuous. Okay, f have a derivative. So f has derivative, and you have to prove f is a continuous one. This is the theorem properties of it. Let us prove. So we have f as a derivative. Given f as a derivative at a point C belongs R1. So this is by definition. What we see the definition as by the definition of derivative f dash of C equal to limit s so and so. We have to prove that f is a continuous at C. So that is to prove that this is the very well known result. This is one definition of continuous. Limit x tends to C, f of x equal to f of C. Now consider, we will consider what f of x equal to f minus f of C. Here I just multiply and divided. What I multiply divided? X minus C. I just multiply divided. Taking limit x tends to C on both sides. So limited. So this portion is nothing f dash of C by the definition of derivative. When you substitute C into our panel, C minus C becomes, CC will get cancelled, 0. So RHS becomes 0. So limit x tends to C f of x minus f of, when you substitute the limit x tends to C, you get same one f of C. Again we take it to right hand side, minus become plus. So this is well known result, f is a continuous at the C. Therefore differentiability gives the continuous. Here I am till the point, every differentiable function is a continuous. What about the converse? Converse need not be true. So in this theorem, what we understand the property, every differentiability definitely will be continuous. Let us see the converse. Note, yes, the converse of the above function is not true. What is the above function? Differentiability gives continuous. That is, it is possible that f dash of C does not exist even though f is continuous. Just link to the point. This is very important. So what is the meaning of the above function? It is possible that f dash of C does not exist even though f continuous இருந்தால் f dash of C exists. Therefore what we say, continuity does not give the differentiability. Continuity வச்சு differentiability சொல்லவே முடியாது. You can say differentiability give the continuous. Now let us see the example. Okay, we see the example. F of x is a mod x. You know mod x property? Yes, modulus of x. So you know modulus property very well. Okay, this is the definition of mod x. F of x equal to x whenever x greater than x. F of x less than 0, then the function we call as a minus x. This is well known result you learned in school levels. When x greater than 0, so x greater than 0, we take this point now. F of x minus f of 0 by x minus x. This is a derivative definition. F of x you can substitute x. F of 0 is always a 0. So divide x by x will get cancelled, we get 1. So f dash, this is 0 plus. What is the meaning of 0 plus? This is the 0 or right hand side. 0 minus the left hand side. When you approach your point, 0 left hand side, right hand side. This is called 0 plus, this is called 0 minus. Now take x less than 0. The same definition. Whenever x is what is the function defined? Minus of x. In the place you substitute minus of x. So my x's will get here, you get minus 1. You see the difference. Left hand side, right hand side approach, you get plus 1. Left hand side approach, I get minus 1. The limit is not same. So f dash of 0 minus 2 minus 1. So LHS equal to not equal to RHS. Even the limit does not exist. LHS limit, RHS limit will be same. Then only came as a derivative. Here it is not the same. So limit s tends to 0. F of x minus f of 0 by x minus 0 does not exist since 1 not equal to minus 1. This implies f is not a differentiable at this 0 in the point f is differentiable in there. But the given function is continuous function. The beauty of the function of the 0 multiplication is the mod x diagram. In the function continuous function, differential of power is a nice proof. Hence, continuity does not give the differential. Continuity is differential, but every differential is a continuous function. This is the nice. You can remember the example. Modulus of x. Let's see the Rolle's theorem. It's a very important problem. Rolle's theorem. What is Rolle's theorem? You have to be a continuous function, a real value function on the enclosed bounded interval, that is a comma b. Generally, we can use a comma b. The maximum value or minimum, whatever, whether you can take maximum or minimum value, is attained at the point C என்ற point attend பண்ணோம். அந்த C எங்க இருக்குனா, that C will be taken from the interval that is closed interval a comma b. And if f dash of C exists, அந்த டெரிவேட்டிவ்ல அந்த பாயிண்ட் போட்டா it becomes a 0. This is the concept of Rolle's theorem. என்ன பண்ணனும் Rolle's theorem ஒண்ணும் இல்ல. Rolle's theorem concept to find the point whether that point gives a maximum value or minimum value. That is the concept of Rolle's theorem. It gives for a முக்கியமான key f dash of C equal to 0. Now let us see the proof. We will prove the theorem with the method of contradiction. What is the contradiction? Initially we assume wrongly something and finally we get a contradictory part. So immediately we can conclude this is not true. So like that we will prove that theorem by the method of contradiction. If possible, let f dash not be C not equal to 0 because in the theorem statement is clearly given f dash of C equal to 0. What I assume f dash of C not equal to 0 vana illadava eduthu. We consider f dash of C not equal to 0, then the either 0 or derivative 0 na there is three possibilities. Math numbers we can three possible. One is 0, another one is greater than 0, another one is less than 0. So already we assume f dash of C not equal to 0. So what is the other two possibilities? Whether f dash is greater than 0 or f dash of C less than 0. We can discuss by case 1, case 2. First I assume case 1 f dash of C greater than 0 by the definition of derivative. You know the definition of derivative, I told many times. Okay. First we consider f dash of C less than 0. So f of x minus f of C less than 0. Less than 0. So this is an interval. Delta is very small value. If taken x from C comma C plus delta, then x minus C is always greater than 0. f dash of c greater than 0. So f of x minus f of c greater than 0. The denominator parts over now and f of x go right hand side. So f of x greater than f of c. It is a contradiction to the fact that f at tensor maximum at c is f dash of c not greater than other. It is contradictory because what theorem say f dash of c da equal to 0 the point like எப்போ maximum or minimum ஆகல இங்க என்ன வாட் ஆஃப்ங்க அதோட ஒரு பெரிய பாயிண்ட் ஒன்று கிடைச்சிச்சு that is x. It is wrong. It is a contradiction to the fact that f at tensor maximum at c only not at any other c. So f dash of c not greater than 0. Number 2, similarly we can assume f of s f dash is less than 0. இதே மாதிரி ஒர்க் அவுட் பண்ணா same procedure you get here also you get contradiction. F dash of c less than 0. This is also contradiction. Now f dash of c less than or equal to 0. Inge not equal. So I put f dash of c neither greater than 0 nor less than 0. Therefore f dash of c equal to 0. So case 1 la we assume f dash of c greater than 0. Ange contradiction vanduchu. Case 2 la less than 0 poda ange contradiction vanduchu. Appo greater than 0 varukadhu less than 0 varukadhu f dash of c should be equal to 0. This is the theorem of Rolle's theorem. Above theorem remains true with maximum value replaced by the we can use whether maximum or minimum in both are same. Next theorem, this is also Rolle's theorem. Yes, what is the working rule of Rolle's? It's a very important point to work out the problem. You have to check each and every step. Verify all the 3 statements are satisfied. You have to check all the 3 statements. Number 1. Second step, you have to find the f dash of x, and after that you find the point c from the interval a comma b. After that, at the point you can find a derivative and equate it to 0, and note that Rolle's theorem is not applicable if neither of the point condition are satisfied. If c not inge very முக்கியமான Rolle's theorem எப்போ applicable ஆகும்னா இந்த இன்டர்வல்ல இருந்து இந்த பாயிண்ட் நீங்க c should be taken open interval a comma b. அப்படி இருந்தா you can work out the problem. Otherwise it's not true. That's very important. If not applicable, if neither of the condition are satisfied, if c வந்து a comma b இல்லனா வைக்காத. So before work out you have to check all the steps. This is useful to work out the problems. This is very important theorem. Very important theorem. Second fundamental theorem on calculus. Very important. This is very simple. We usually do in school level. When you integrate 0 to 1 x dx, what happens? You know integration x square by 2. 0 to 1. Usually what to do? Upper limit minus lower limit. What is upper limit? This is upper. This is called upper. You know very well. This is called lower. Wherever x you can substitute the value. So what happens? In the place of x you just substitute 1 square becomes 1 only, 1 by 2 minus 0. 1 by 2 equal to 1 by 2. This is the theorem. This we did in plus 2 level always. Okay, this is the theorem. Second fundamental theorem of function. If f is a continuous and a closed bounded interval a comma b, if pi of x equal to f of pi dash of x, look at that, pi dash of x equal to f of x, s lies between a and b, then it's important, a to b f of x d is equal to pi of x, this is pi of x, and minus pi of x, this is pi of x. This is an ordinary integration, this is second fundamental theorem. Now let's look at the proof. Let f of x be a to x f of t dt, then by previous year this is the standard result. F of x equal to integral a to x f of t dt. Given what they given, this is the given. Pi dash of x equal to f of x. X raised to a and b. F dash of x equal to pi dash of x. So you can write directly capital F dash of x. Every x also belongs to a comma b. By theorem, f of x equal to this well-known theorem. By theorem 1.84, f of x equal to pi of x plus c. You just replace in the place of x b, what happened? Pi of b plus c, and replace it a, pi of a plus c. Well, now you can subtract f of b minus f of a equal to, you just subtract both, and then what happened? C cancel, so you can remove the constant. So pi of a minus pi of a, it's a bracket, this c will get cancelled. So pi of b minus pi of a. From equation 1, f of b equal to a to b f of t dt, and equation f of a, and in the place of b can substitute a, no, this is a, f of t dt. When you integrate this function, upper limit level same ஆகிறதுனால after the integrate, after the substitution of limit, this is also 0. So f of b minus f of a, you can take only this value, this becomes 0. Then this is the result. A to b f of t dt phi of b minus phi of a, because f of b minus f of a already found it, phi of b minus phi of a. So this is a proof of it. If you are able to result, then only calculate the problem. This set of measure 0. It's an important concept. Nice concept also. First, let us see the definition of what is measure 0. The subset E, okay, the subset E of R1, R1 E is subset E is said to be of measure 0. You can say this E is measure 0. You set it measure 0. If for every each epsilon greater than 0, there exists a finite or finite or countable number of open intervals. You can collect the countable number of. See, this is the countable number of open intervals. I1, I2, dot and In. Everything belongs to E. So E you can write countable union of generally union of n In. And you can do the modulus. You can do the modulus of In. That value add panni and intervals add panni modulus potina. That value should be lesser than epsilon. Modulus and denote the length of the In only length. In means what? I1 plus I2 plus I3 all add panni. அது மாடல் லென்த் போட்டிங்கன்னா அந்த மாடல்ஸ் லென்த் போட்டிங்கன்னா அவர் என்ன ஆகிடுவார் எப்சிலானோட கம்மியாக இருப்பார். அந்த மாதிரி இருந்துச்சுன்னா அதான் மெஷர். ஒரே சிம்பிளே R1 E எடுக்கணும். அந்த E சப்செட்டில் கவுண்டபிள் யூனிட் ஓப்பன் ரூல் போட்டு அதெல்லாம் ஆட் பண்ணி எப்சிலானோட கம்மியாக வந்துச்சுன்னா அது செட்டுக்கு இருந்தால் என்ன அர்த்தம் உங்களுக்கு மெஷர் 0. இங்கே மெஷர் சி E. In other words, so other way to tell the definition, E is of measure 0. E measure 0. If given epsilon greater than 0, E can be covered by union of open interval. Yes, important. Union of open interval whose length add up to less than epsilon. This is a different way. Nice example. Singleton set. Singleton set வந்து measure 0 because singleton setல பார்த்தீங்கன்னா ஒரே ஒரு நம்பர் தான். அங்கே நீங்கள் கவுண்ட்லாம் போட்டால் கூட obviously less than epsilon, not more than 1. மொத்த எலமெண்ட் தான். அதனால் you can remember measure 0 example வந்து singleton set. Okay, I just tell one theorem. If each of the subset E1, E2, E3 of R, this is R, is one is of measure 0, then union, subset எல்லாம் எடுத்து Rல இருந்து எல்லாமே measure 0 வரும். அந்த யூனியன் போட்டா கூட so யூனியன் போட்டா கூட அது என்ன வரும் measure 0. This is important. So every collect all the subset E1, E2, everything is measure 0. You put the union of all the measure set போட்டா வரக்கூடிய answer also measure 0. This is a measure 0 definition and also theorem. Thank you.